Um, this is a question that was, well, not this question in particular, but I was asked by a team that I met during my Team Math Challenge regional finals. And this particular team asked me to do a geometry question. And this is kind of a simple little geometry question. It's Olympiad level geometry question. And this particular team are renowned for their green uniform. So you know who you are. You know who you are. Um, and this question comes from the 1999 JMO Junior Math Olympiad, question B2. So it's a slightly longer questions. And it reads, AOC is a straight line, and the angle AOB equals to 42 degrees. OP and OQ, trisect the angle AOB, which means they divide the angle into three equal parts. OR and OS trisect the angle BOC. That trisects this side. Show all working. Calculate the angle QOR. QOR. So this angle here. And POS, which is a slightly larger angle there. So let's start with QOR. Well, in order to work out QOR, well, we're going to need two bits, I suppose. We're going to need this bit, and then we're also going to need the other side here. We're going to need this side here. So let's start with QOB. So I need QOB plus the BOR. Now QOB, because it trisects the angle AOB, well, that's going to be, I think that's the easy one. AOB is 42 divided by 3. And that's the angle there. BOR, well, that's the larger part, which is, well, it's going to be 180 minus the 42 divided by 3. Oh, and that's not meant to be an equal sign in between. It's meant to be a plus sign in between. And there's a plus sign there. And that's the angle at the end. And 42 divided by 3 gives us 14. And then that's 138 divided by 3, which is 14 degrees plus 120 plus 18. So that's 40 and 6. So that's 46 degrees, which means that in total it's going to add up to 60 degrees. So that's QOR. Now, SOP, well, if you notice that if these two are the same and these two are the same, well, you can say that SOP equals 2 times QOB, QOR. Well, and that means that, well, it's 120 degrees. And that's part A. That's part A done. So I'm just going to make it smaller. And that's part A done. And then part B. It says calculate QOR, well, same, the small angle again, so QOR, when angle AOB equals to X degrees. So this one we don't know what it is, because AOB is now, this entire thing is X degrees. But we're going to do the same thing. So QOR is going to equal to QOB plus BOR. But this time, what's QOB? Well, it's the angle here, X, divided by 3. And BOR, well, this is going to be 180, instead of minusing 42, it's going to be minus X. And then, well, luckily they have the same common denominator, which means I can write it like this. And then X cancels, and that leaves 180 divided by 3 and it equals to 60 degrees. And then done. This question is done. Now, the reason why I chose this question is not because, well, I can solve it, um, but and not because I can show people that I can solve it, but I want people to understand, well, what is this question actually talking about? Why is it that these two happen to be 60 degrees? It's not really by chance, but you need to think about what's going on. You need to think about what's going on. And in terms of this question, we've got one small angle and we take 1/3 of the smaller angle. And then we add to it the other side of the remaining angle and we take 1/3 of that angle. And then when you have a 1/3 of a smaller bit and you add to it 1/3 of the larger bit, well, then you're going to have 1/3 of the whole thing. And the whole thing is what? Well, the whole thing in this case is 180. Let me show you in a kind of in almost like a silly example. So imagine if I had a semicircular cake again. Well, not quite a semicircular cake. And let's say I cut it into 2 bits. And in here, they cut it into a very nice origin. I'm going to be not so nice. And then so I'm just going to cut it into some random bit, not even necessarily a straight line. So no relation from one bit to the other, mathematically speaking. However, if you said, well, if these 2 pieces, you gave somebody 1/3 of the smaller bit, and then you gave that same person 1/3 of the larger bit, are you happy that that person must have had 1/3 of the entire thing, irrespective of how you cut it? So you don't have to cut it into very nice angles or any nice shape. You just need to know that out of these 2 small bits, well, these 2 smaller bits, if you gave 1/3 of one part to someone and then 1/3 of the other part to someone, in total, you must have given them 1/3 of the entire thing, irrespective of how you did it. So here, if it's 180s, you cut it into 2 parts. Well, 1/3 is 1/3, and 1/3 of the other is 1/3 again. So in total, you're given 1/3 of 180. So that's why in both cases, it's 60 degrees. So if you wanted to for part B, you would quite easily have said, well, if you have 1/3 of the smaller and 1/3 of the larger, and those 2 equals 180, you must have 1/3 of 180. You didn't even need to write the algebra if you don't want to. And it shows that you have a deeper understanding of what's going on with this particular question.